Okay, everyone. We'll go ahead and get started. I'm very excited to be here. This is the last session of the last day of NDC Oslo. So everybody here watching, you are the real heroes of the conference. This will be a good session, though. This should be a pretty fun one. So I'm Jeff Hollan. I'm program manager working inside of Azure back in Seattle, Washington. And I'm on the Azure Functions team. So I'm program manager for Azure Functions, which is one of the core pieces of serverless for Microsoft Azure. That said, a lot of what I'm going to be talking today are going to be some of the concepts to know about for Azure Functions, but they are not necessarily unique to Azure at all. A lot of these practices are good for any, even distributed system all around, but especially around serverless. So whether you do or don't use Azure, this should still be useful for you. But do use Azure. You won't be sorry about it. So we're going to go into a little bit of an intro of functions and serverless, but we're going to spend a lot of our times on best practices, architecture, and some examples. So with that said, in case you aren't already familiar, what are Azure Functions? And the very basic definition of this is Azure Functions, much like other serverless providers, allow you to have your code executed in response to some event. So in this case, I've got a really simple code sample. This is in C#, and all this is saying is I'm going to get an HTTP trigger request to some endpoint, and whenever that request comes in, I want you to run this little bit of code here. Now, the code you might want to run might be, schedule-based. Hey, I want you to run this SQL query every day at 1 o'clock p.m. It might be message-based, like every time a message shows up on some queue, or stream-based, like stream this data and constantly process it as it comes in. But it gives you as a developer the flexibility to just write your code and not have to worry about the scale, the hosting, the resiliency of the service. That's all managed for you out of the box from Azure. Azure Functions. Let me grab a drink real quick. So with that said, a term that you have probably heard a lot of this conference. There's been some great sessions already. Very brief definition, I'm going to jump right through this, which is what is serverless? Azure Functions is a serverless technology. And serverless is about an abstraction of servers, first and foremost. Like when I publish that code that I just showed you, I'm not worried about how to host, maintain, patch, and secure the servers behind the scenes. I just focus on my code. It is event-driven. The resources to run your code are provisioned automatically for you on demand at whatever scale you might be requesting. So you attach it to some type of event. I've already given some examples of those already. And you're only billed for when your code is actually running. So if I did have a serverless API and nobody called it during the entire month, I wouldn't be charged a dime. And then if the next day all of a sudden I got thousands of requests, I'd only be charged for those thousands of requests. Now, Azure, the serverless platform, looks a little bit different than you might see in other cloud providers. There's actually 3 core components. We're not going to spend a lot of time in these right to, but I think it's important to note as you consider what a serverless architecture might be formed of. So the first one, you have functions. This is the code that you write and publish, code that you want to run off of some event. In Azure, there's also something called Azure Logic Apps. I'll show you just briefly what one of these looks like in a second, but these are workflows. This enables you to orchestrate code or data in a serverless fashion. And there's also a service called Azure Event Grid, which allows you to route your events to different pieces of your architecture. So you might say, hey, I want to be notified whenever something happens on my virtual machine or on my storage account, or I want to be notified whenever an employee is hired by my company so I can go do something. An Event Grid is the platform piece that lets you route that information. Now, on top of it, it's very likely that a full application isn't just going to be serverless code, serverless workflow, and events. You're going to need data. You're going to need security, potentially for like user logins, potentially some intelligence on top of it as well. So you get rich integration with a bunch of other services inside of the Azure cloud to do things like store your data in a NoSQL database or run machine learning to give order recommendations. Like maybe you have an ordering API and you want to send them an email and say, hey, you might also be interested in these items. Weaving those types of intelligent services is very easy as well. And then something we're very proud of in Azure that Microsoft's obviously always taken very seriously is the development tooling. So I'll go through a bunch of this today, whether it's monitoring, developing, testing, or even continuous integration and continuous deployment. Okay, so that's kind of the overview of serverless. Many of you might have already known much of this. Let's talk about some examples. And one of the reasons that I personally really love serverless is just because it's changed how I am able to write applications. So the first cloud app I ever wrote was actually an app for the Microsoft Band, if you were familiar with that short-lived product from Microsoft. This is a picture of the app here. What it was a simple app so that if you were a fan of sports, you could open up the app and you could say, hey, I want to know about NBA scores or football scores or whatever scores it might be. And your band would then talk to the cloud. I would get the sports score of whatever game was happening and send it to your wrist. For a point-in-time reference, I built this in 2015, right around the same time that the Apple Watch was released. This was the first application I'd ever written that was callable through the cloud. It wasn't just like some app that ran on a box. It took me about a month to build. I spent a lot of time building this. It was a good learning exercise. And I was spending $80 a month for the server behind the scenes that was powering this application. When I had one user, I was paying $80 a month. And even, this is actually a picture from a news article that picked up this app when Microsoft Band was just taking off. And when this news article hit, I got 1,000 downloads like in one day, and it kept growing. I was still paying $80 a month, but I also struggled to kind of manage the spike in usage that I was seeing. The other challenge was because of this was kind of built as just my VM with a bunch of code that I jerry-rigged together. One of the biggest pieces of feedback I got when I first shipped this was, hey, we want to be able to follow Premier League or World Cup or whatever else it might be. And so to add additional features was taking me a really long time and was hard to update because I just, again, had this virtual machine. So cool app, fun experience, but took me a long time to build and was painful to manage. Now, if I look at this year, some of the different apps that I've built, this is just one example of one of the apps that I've built. This is actually a picture of my doorbell at my house. I have an IoT doorbell that has a camera on it, and it will be able to detect motion or sound. And I wanted to be able to use that feed from my doorbell to do some intelligent stuff. So what actually happens is when somebody comes to my door, you can see an image of the end result. I'll actually run this video feed through some intelligent services. If you've given me access to know your identity, then I can actually do some facial recognition. I can detect the text if any text is being spoken. And all this is just running, monitoring my doorbell 24/7. This only took me 2 evenings to build. I actually wrote a few blogs about how it was put together if you're interested. And just like I mentioned with serverless, this is only ever running when somebody actually comes to my door. I don't have a lot of visitors. I'm not super popular. So this means I'm only spending about $4 a month right now to constantly be monitoring my doorbell. And a lot of that cost is actually from the NoSQL database. The functions themselves are actually $0. They're free because I'm not calling them enough. This will automatically scale to any traffic, and it's extensible and reusable. So to give you a sense for what kind of a serverless app can look like in Azure, I do want to piece apart this doorbell one. Okay, so just an example, this is Visual Studio Code. And for this app, my doorbell one, it's actually written in JavaScript. So I just have here a very simple Java function, which says, hey, on a timer, every 15 seconds, go and check to see if anybody is ringing my doorbell. If somebody is ringing my doorbell, I want to send an event out to let me know that someone rang my doorbell. And then it keeps running and keeps checking my doorbell. So not a bunch of complex code I have to write. Just check to see if somebody's at my door. If somebody's at my door, notify my application. Some of the nice things to call out, I talked about dev tooling. I've got this extension directly inside of Visual Studio Code for Azure Functions, where I can create, update, and publish my functions all from within this experience. I can even do things like set a breakpoint and F5 run, and this will actually spin up the Azure Functions runtime inside of Visual Studio Code so that I could debug this live and hit a breakpoint. So you'll see here with all this moving text, this is just spun up. It's now checking locally on my machine here. I think I've set this one to schedule every 15 seconds. So within about 10 seconds or so, you'll actually see this breakpoint would get hit. So some really nice tooling in here as well to help me build these, in this case, a JavaScript function. Now, what happens when that event gets sent? Because this function's not doing a whole lot, right? That's not powering all that cool machine learning stuff I showed you a second ago. And what's powering all of that, this is the only part you're going to be able to see Azure Logic Apps today, so don't blink. This is actually the workflow that gets kicked off from that event that's running in my subscription, okay? So you can see here's some of the different runs that have happened. I can click into them and see the status. If I actually click edit, this is what an Azure Logic Apps looks like. This is a very useful tool for functions and for serverless to orchestrate events. So here I'm listening for that doorbell event. So I'm saying, hey, wait to see if my function sees that someone's at my doorbell. And now I'm going to execute this process, which can be pretty long running. The first thing is I'm going to wait until the recording is finished. This could take a few minutes until somebody finally leaves my doorstep. Once I know the recording is finished, I'm actually going to upload that recording to an out-of-the-box connector here inside of Azure. So this is a connector for one of the cognitive services or artificial intelligence services in Azure that can actually take a video feed and automatically process emotions, faces, text, all that other good stuff. So I'll go ahead and push that up here. I'll wait for that video to be processed, and then I can store the data here. One other thing I'll show you in case you haven't seen Logic Apps before, if I wanted to continue to add some more stuff when someone rings my doorbell, I've got all of these, not only Azure functions that I can call, I could also call containers running in Azure container instances. I could call other connectors like Dynamics, GitHub, whatever service I might be using. This is probably code I don't have to write. So this is great. It's awesome. And now, within 2 evenings, I have this code that's constantly running and listening for when someone's at my doorbell. So just an example of what a serverless app can look like. Okay, now we're going to spend the whole rest of the time talking about functions. So that's the serverless architecture piece. Let's go deeper into functions now. A few key concepts to note. When you're writing Azure functions, the core component that you're dealing with is a function app. And an app is your unit of deployment. It's your unit of development. It's also the unit of scale. So a single app will be scaled as a unit. You can have multiple functions in an app, but your app is your primary unit of development, deployment, and scale. And it can have many functions inside of it. So again, just to kind of tie the knots together, if you come back here to my doorbell project, this is my app here. This is my function app, but I actually have a few different functions. I have check the rings, I have get the current recording, I have store some data in Cosmos DB. These are all different functions, but they all live in the same app. So I can develop them and deploy them together. All of your functions will have a trigger. This is the event source that it's listening for and the data that will be passed in to let your function know to execute. Every function can only have one trigger, and the service itself will automatically be listening to that source. So you're not charged if it's listening to something like a queue waiting for a message to drop. You're only charged once that trigger fires and your code actually runs. The other piece which is unique to Azure Functions is this concept called bindings. These can be super useful for you as you're developing your functions. Bindings are data that you can pull in or push out of your function without having to integrate with that service directly inside of code. So I have here a table. These are like our top, 7 or 8 triggers and bindings that we have. An example, and I'll walk through this in just a second, I might want to build a serverless API with Azure Functions. So HTTP would be the trigger. I'm going to be listening for an HTTP request. But maybe I want to store some data from that request in a database, in a NoSQL database like Cosmos DB. Now, I don't necessarily want to have to write and manage my connection to Cosmos DB, so I can use a binding to automatically push data to Cosmos DB as part of my execution. And I can describe that integration through configuration. I'll show that to you in a second. Alternatively, maybe my endpoint, I'm getting in a query parameter for like an ID or a path parameter for an ID. And I know that that ID maps to some data in my storage account or like table storage. Maybe I actually want to pull in data from storage at the time of execution. I can use an input binding to tell my function, hey, you're going to be triggered from HTTP, but also pull in data from Cosmos or storage or wherever else at the time of execution. If that doesn't make sense right now, that's okay. I'm going to show it to you in just a second. But just remember, we have triggers that start your event and bindings which can allow you to flow data in and out independent of the trigger. Now, one of the nice things about Azure Functions is that you do have a number of different choices on where and how you want to develop. I actually have some recommendations here, though. So you can write and manage Azure Functions entirely in the Azure portal. There's a little code editor. You can run and test. I wouldn't recommend it for anything in production, though. It's great for trying things out. If you have a really simple script and you just want to play around with Azure Functions, or it's not a very important script, it's fine. But anything you're doing that will have the words production associated with it, you're going to want to use one of these other editors, because then you can do things like source control and continuous integration and automated testing and all of the best practices that you've been hearing about. So Visual Studio, this is perfect for C#, F#, anything .NET related. There's a really nice Visual Studio integrated tooling that gives you debugging, publishing, integration with Azure Functions. It's perfect for that. You can use Visual Studio Code. I showed you I'm using my Mac right now, so I have Visual Studio Code. Visual Studio Code does support C#, but if you have the option, I do think Visual Studio is a more natural place to do that for now, at least, for me personally. But if you're writing JavaScript, Java, or Python functions, Visual Studio Code is a great fit. Again, it has that out-of-the-box extension. We also have Maven tooling for Java functions, so you could write your functions in IntelliJ or Eclipse if there's a different Java editor you care about. And really, the tools can be run anywhere, so if there's an editor here that you like that I haven't listed, it will still work. You just need to make sure you hook it up to our CLI tools so that it runs for you. Okay, so I want to show you what this looks like now. I'm going to do a really quick walkthrough of building a function inside of Visual Studio, this time from scratch, okay? And the one I want to build is actually what I described a little bit in the example. So I want to build an API, and I have here a Cosmos DB NoSQL database inside of my Azure account. And I want to make an API so I can get a request, have that function spin up on demand, and then push that data directly into Cosmos DB. So let's go ahead and do that. I'm going to go ahead here and say File, New Project, and create a brand new Azure Function project. I can choose whether I want to do this in our version 1. I'll zoom in here. I know this is really small. In our version 1 runtime, which is currently generally available, which is written and runs .NET Framework functions, or our version 2 one, which is in preview and will be in preview for a few more weeks, which is .NET Standard. It actually runs .NET Core 2.1, which gives it some nice benefits. I'm actually going to go ahead and do this in the version 2 .NET Core one. And let's go ahead and say we want I'm just going to do an empty project for now, okay? So here's an empty project inside of Visual Studio. I don't have any functions here yet. So let's go ahead and add one into this app. Remember, this is my app, and an app can have many functions. And this is my unit of development, deployment, and scale. So let's add a function into this project, and there's a bunch of different triggers that I could choose from. I already mentioned I want this to be an API, so let's do HTTP triggered, and this will start for us right here, okay? Let me make sure our code is big enough so that you can see a little bit of what's going on. 200%, yes, please. I guess it doesn't like to zoom. Hopefully this won't crash. If so, that's fine. We'll have to move on from there. This is what I get for running inside of a virtual machine on my Mac on battery power. It looks like it didn't like it. That's okay. Don't zoom in your code live. But that code right there was just an HTTP function. I won't show you for the sake of waiting for this to reboot and making sure we have time to go into some other topics as we move forward. But I could do the same thing I did in Visual Studio Code, set a breakpoint, click the run button, and everything would run for me. And I'll do that in a second. Okay, now this is great, but I need to integrate now with Cosmos DB. And I'm going to use that concept called bindings, okay? So I don't want to necessarily have to write the integration code with Cosmos DB directly. I'd rather leverage these bindings. So one important thing to note is that functions, you can pull in different extensions, okay? So we have an extension for Cosmos DB. We have an extension for Service Bus Queues. We have an extension for Azure Event Grid. These are all published through NuGet. So in this case, the first thing I'm going to do is make sure I pull in the extension for Cosmos DB. And I actually have a nice keyboard shortcut, which is going to give me all the code here. So I'm going to say, hey, in my function app, I want to install the extension for Cosmos DB. The reason that we make you install these as extensions is because we want the base image to be as lightweight as possible, so you get really good performance. So if you want to bring in any integrations with other services, we have you install them in through NuGet. If you're using JavaScript or Java, those toolings have different ways to do those packages, but I won't go into those now. All right, so now this is where I want to define how that integration works in my function. This is where I'm actually going to write my binding. I'm going to paste this in right now, and then I'll walk through it, okay? So what I've done here is I've written an attribute on this function, I've said, hey, I want you to integrate with Cosmos DB. I have a database called function. I have a collection called function. And I have a connection string, which is going to be in an environment variable called Cosmos DB connection. Okay? I don't want to paste my actual connection string here, because you don't want to put secrets inside of your code. So I'm actually just referencing an environment variable, which I'll set in just a second. Now, what it's telling this to do is I'm going to have this variable called docs, which is an out variable in my parameter. Whatever I set to docs, in this case it's a string. I could make it a document. I could change the type depending on what type I want to use. But let's just leave it as a string for now. Whatever I set as the value of docs, that's what it's going to push into Cosmos DB for me. Okay? So I'm going to set this value for docs and push that to this Cosmos DB database. So the only code I have to write is, hey, let's set that docs variable to the request body that I get from the HTTP request. Okay? So with that one line of code and this attribute up here, now whatever is in my request body is going to create a record in my Cosmos DB database. Obviously, I could manipulate and do whatever I want to do with it. Now, the last part I need to do here before this will actually work is I need to make sure that I'm setting this environment variable. Okay? So locally, I have this handy file, which you probably can't read very well, called local.settings.json. And that will let me set local environment variables easier. In the cloud, they're called application settings. But let's go ahead here and we'll say, hey, I have this environment variable, and I want it to connect to this really long connection string. No one used this Cosmos DB database. No one looked at the video recording. OK, so that's it. So that's my function that I wrote quickly here. I use bindings to make my life a little bit easier. And now, let's go ahead and run this and test it out. OK, so I'm going to go ahead and click the Run button. I don't know where my Solution Explorer went. Things kind of wigged out on me a second ago, but it doesn't really matter. OK, so I'm now running this code. I have my Azure Functions runtime, which is spun up inside of Visual Studio. This is the exact same runtime that will be running when I publish to the cloud. So I know that if it works on my local machine, it will work when I publish it, because it's the same runtime that's running here. It's given me this nice endpoint that I can test locally. So here's my Azure function now that I can test on my machine. So let's go ahead and copy this endpoint. I'm just going to send a request using Postman. This Windows machine is really struggling, but that's OK. All right, so I'm going to send a request to that endpoint, and I'm going to pass in this request body. The Shift key is like locked right now, but I'm not too worried about it, I don't think. So let's just keep going. All right, so let's go ahead and click Send. It's gone ahead now and fired off that function. In fact, if I come back over here to the logs, it returned back, hello, Jeff. I could change this to whatever I want it to as well, like hello, NDC. And go ahead and send this again. And now it says hello, NDC. And I can actually see my logs that have been generated here. And just to prove that this worked, let's come look at this Cosmos DB database now in the cloud. And if I click refresh, we should now see two new documents that got created for me. One with the request body of name is NDC. And this is just the metadata that Cosmos DB generates. And the other one, which is named Jeff. So now I have this function that I could write, check into source control, and then deploy once I'm ready to go, which is now integrating with Cosmos DB as an Azure function. Okay? So hopefully, if you hadn't used functions before, that's a bit of a walkthrough of how some of those concepts weave into what a function looks like. OK, so now that you've seen functions, it's useful to know some of the common architectures where I've seen these fit in very well with some of our customers. So here's the top 5 scenarios that I've seen. The first one is anytime you have an event stream that you want to be doing some processing on. So these events might be IoT events coming from IoT devices or machinery, anything that's like in an event hub or Kafka, something that's pushing a ton of data, diagnostic logs, whatever it is. Because the nice part about functions is that I can just write the code I want to execute for a single event and click publish, and now that piece of code will run for every single event that's happening. So it's kind of very easy to just attach this to the stream and have it scale automatically to do some processing on top of that stream. Web APIs and mobile backends is another very popular one. One of our larger customers has a mobile app for a retail store. And how it works is if you want to send somebody like a gift card, you open up the mobile app and you're like, hey, I want to send Jeff $20. and you select my account, and you click send. When you click that send button, it's actually kicking off some Azure functions behind the scenes, which go and charge their account, send the email, do all those other great things. And it's a great fit for them because they don't have to worry about managing this API and scaling it. They just publish this as a function, and it works. You'll hear serverless often used and talked about as glue between systems. You might have a bunch of data that's in some file system, and you want that data in a SQL database or in a NoSQL database. Being able to just really simply write a function and say, hey, whenever new data gets added or every hour, go pull the data and push it over to this system is a really nice fit to just kind of glue things together. If you're using pub sub, queues and topics and routing, functions are really good actions on top of those pub sub ESB type patterns. And then for just general automation or scripting, if there's ever a task that you're doing that you want to automate, something very simple, like recently I was just on a call with a customer who uses functions to help automate their pull request process. So they have it so that whenever anybody opens up a pull request, it fires off a function that does some code checks very quickly for them. They don't have pull requests happening 24/7, but whenever they do, now this code can run. One of the customers, I'll just share one use case. Carl Zeiss, who does very high-end electronics and imaging devices. They've been using Azure Functions. There's a use case they published to customers.microsoft.com that monitors and scales to field devices that are connecting to back-end REST APIs, and that's all powered by functions. And just to kind of bring the point home, and so I'm not the only one saying it, the thing that they call out is that the scalability of Azure Functions is amazing. They can send millions of records, and the platform adjusts automatically to the load. So very low operations and very high scale. Okay, now let's talk about some more advanced tips and best practices. These are some of the common hiccups that I see people do. When there's a support ticket that comes in or somebody says, hey, Jeff, I tried to use functions and things aren't working as I expected. These are some of the top things that I've seen and how to get around them. The first is another concept to understand, which is how instances and resources are managed. Actually, I do want to show you this because it's a little bit easier to show. So let's come back here to this. Let me open up my Solution Explorer, wherever that went. What do I do? View here, View Solution Explorer. So this Azure function, okay, very simple, REST API. This is in my app. Let's say I go ahead now and publish this to the cloud, okay? I have one just like this. It's already published, so I'm not going to go through this now. And what I do want to show, though, is I have here a live stream connected to application insights. So one of the tips is hook your Azure functions into a monitoring solution like application insights, which we integrate with out of the box, because it will give you insights and observability into how your function is performing. Now, what I'm going to do here is that I actually have a script ready to run, which uses a load testing tool called Artillery. And I want to simulate 1,000 requests happening every single second at one of those function APIs like I just wrote, okay? Now, nothing has been called yet. Like, this thing is totally empty. In fact, just to show this, I'll call it one time really quickly. Let's call this API. And you'll see what happens here in our live monitoring is that I can actually see that an instance has now spun up to execute that request, right? And it's already done. You see I had one execution that happened, one lonely execution. Now, I'm going to run this load test. I'm going to push 1,000 requests a second at this function. And I want you to pay attention to the instances down here. So there's 1,000 requests coming in, and you'll see how quickly and how many servers are going to be scaled up behind the scenes to process this load. So suspense now is high. Let's go ahead and run this test. Let me wait for it to start up and initialize. I think it should be going. So we'll come back here. Yep, it started up. So you'll see already before I finished my first sentence, we're at 4 servers that have spun up online and are helping process the request. In fact, it's seeing that the load isn't stopping, so now it's at 5 servers, 6 servers. Very quickly, this has been able to scale up as the request per second continues to increase. 7 servers, you can see a counter up here, 8 servers. This is nice. If any of you have had to deploy a server before, it usually is not as quick as this sentence that I'm completing right now. But already that function that we wrote a second ago is now processing across 9 different servers. And it looks like it's hitting about 500 requests a second right now. The request duration is still really low, so I don't know if my computer is bogged down by me having too many things open and it's not sending more than 500 a second. But that's okay. Regardless, you can see I'm processing 500 requests a second across 9 fully powered Azure servers running right now. It looks like this is very happy at 500 requests a second, so I'm just going to stop this right now to save my computer from blowing up. Okay, so we'll go ahead and stop that, okay? So a few things to note as we talk about what just happened. So Azure Functions will automatically add instances or servers as needed. In this case, for this load test, it realized it needs 9 fully powered servers running in the cloud to process that load. Each of those instances will have my app running on top of it, okay? So that same runtime you saw me running in Visual Studio, those are running on all of those instances. Now, every single one of those instances may be executing multiple things in parallel, right? These are powerful servers. I don't need to just do one request per server. I could be processing multiple requests in parallel per instance. So there is some parallelism here happening even on top of an instance for a single instance. Now, the reason this is important, and one of the best practices to know, is that you can take advantage of the fact that, yes, there are servers powering serverless, and you can reuse certain resources across executions. So for example, a very common example of this is a sequelClient in your code. Maybe your code needs to talk to a SQL database and you're using sequelClient. A very common mistake that people make is that in their code, they will do something like var sequelClient equals new sequelClient and then my connection string. Now the problem with this is that every single time my function execute, it's going to instantiate a brand new SQL and have to establish a brand new connection to that SQL server. But we're not throwing away your servers after every single execution. In fact, you'll notice if I even come back here to the monitoring solution we have, I still have 9 servers online. All of the code that I instantiated, all of the public or private static variables are still set. They still preserve their values. So if I would have done something like private static SQLClient, that SQLClient would have only had to establish one connection, and that connection could still be alive, and I could reuse it for subsequent executions, okay? So again, here's the anti-pattern that I see a lot of people do. HTTP client is the other one that comes up a lot. This is an anti-pattern for a number of reasons. If you're interested, there's a link down here, okay? So here's my function code. Doesn't matter the language. If I do something like using var client equals new HTTP client, that means for every one of those 1,000 requests that are coming in, I'm having to instantiate a whole new HTTP client. My instance is going to be really inefficient, but I'm also going to exhaust the available sockets pretty quickly because there's only a limited amount of sockets I have on one of these VMs, and if I'm pushing high load, I'm going to exhaust them just because I'm not managing things very well, okay? So again, there's a link here if you're interested. Just remember, these instances are established, but you can actually reuse resources across them. You can almost have kind of simple caches as well. So the better way to do this, I'm going to create an HTTP client as a singleton, in this case, a private static HTTP client. This is thread safe. And what this will enable me to do is now, as multiple requests are coming in, I can reuse the same client and make multiple requests. So my code's going to be a lot more performant. It's going to scale a lot nicer, and I'm not going to run out of sockets, okay? So this could be sequelClient. This could be Event Hub client. This could even be some type of an in-memory dictionary or cache. And that's going to hang around. You can keep reusing that as you want. So very, very important tip that's going to make a big difference. And if you don't do it, things might start working quirky for you. Okay, moving right along, because I want to give plenty of time for durable. The last tip I'm going to give in regards to scale, I'm going to paint a little story for you, okay? So if you think about this example we just did with the HTTP load test, where unfortunately I wasn't able to push a big enough load. That's okay. Imagine that we have 2 cities, okay? City A and City B, and everybody on City A wants to get over to City B. And let's say there's 1,000 people who want to get across, and I have 1 boat. Now the question that I have to answer is how many people can I fit on 1 boat for 1 trip to City B? Now, if these are small children, right, maybe they're like 5 years old, maybe I could fit like 30 people on one of those boat trips. And that's cool because it means I have to take less trips back and forth. But if they're bigger people, maybe it's like 1,000 people who are my size. Maybe I can only fit like 2 or 3 people on one of these boats before I get worried about it, okay? Don't worry, I'm going to tie this back into functions, I promise. Now, even if I have multiple boats, like maybe I have 10 boats or 20 boats, there's still the question I have to answer, which is how many people can fit on a single boat at one time. Maybe I have 1,000 boats, and that's okay, but I want to make sure that I don't load too much onto a single boat by itself, okay? So just remember that. Things can scale out across multiple boats, but I need to make sure I'm aware of how many things can fit on a boat at one time. Now, what does this have to do with Azure Functions? So you just saw for that HTTP example that I scaled out to a bunch of different instances. And the service itself does as good of a job as it can to allocate and distribute your load so that each of these instances isn't processing too much. We do our best effort. But sometimes our best effort isn't perfect, okay? And we understand that we're not perfect at this. And so we may do something like push too many executions onto one instance at one time. We would overfill your boat, okay? So you want to make sure that your function isn't having to execute too much on one of these single instances. Now in Azure Functions, just so you know, a single instance is 1.5 gigs of memory and 1 core of CPU. So you can think in terms of how much can I process in 1.5 gigs of memory and 1 core CPU. If for some reason we've gotten the math wrong, you're using some of the monitoring like I've just shown you, and it looks like we're overloading an instance, like its memory utilization is bad, or it's starting to time out or get overwhelmed, we do give you this configuration file, which is called the host.json file, where you can actually tell us how much we can send and how much data we can push to a single instance. And that will allow our scaling to compensate for it and scale out appropriately, okay? So in this case, for like a very simple, if I'm just doing simple addition, like, hey, take value 1 and add it to value 2, I could probably be doing 100 of those in parallel at a time. It's not doing that much work. But maybe I'm doing like Bitcoin mining or cryptocurrency. It's not profitable, don't do it on functions. But if I was, that's probably more memory or CPU intensive. I might want to tell Azure Functions, hey, don't send too much on a single instance, okay? There's a lot more information here in terms of scalability so that you can control how functions scale to preserve things like downstream systems. I'm not going to go into that right now, but just note that there's a lot of config here that you should be aware of. And this again applies to just distributed systems and parallel processing in general. Okay, the other thing I'll let you know is that with Azure Functions, you do have a lot of flexibility in that you can run your function in your ideal environment. So up until this point, I pretty much talked exclusively about consumption functions. These are functions that run in the serverless plan. You only pay for what you use. We only allocate resources for you on demand. But that's only one of the many different flavors that your functions can run in. You can run your Azure Functions in what's called an app service plan. This is like the website plan inside of Azure. And this plan allows you to reserve and have reserved capacity for your functions. So instead of saying, hey, spin these up on demand, you could say, hey, I want 20 instances that are my instances that I can manage how I want, choose different hardware configurations, maybe even have websites or other processes running on top of it. You can still deploy your functions to run there. You can run in your own dedicated, isolated environments connected to things like VNets. You can run on premises with Azure Stack. There's also an on-premises, which is called Azure Functions Runtime, which is similar to the runtime I just had in Visual Studio, which doesn't require the full Azure Stack. And finally, you can run your Azure Functions on IoT devices. So that same function that I just wrote at the beginning, if I wanted to, and I've done demos like this before, if I had a Raspberry Pi sitting next to me, like a really simple IoT device, I could deploy and have that function run on that IoT device as well, connected or disconnected. So you can have kind of take advantage of this programming model, but then host it in the environment that best fits you. Okay, so we've got about 20 minutes left. We'll probably maybe even finish a little bit early in case there's questions, and this is the last session. So the last thing I want to talk about is how you can orchestrate processes with functions. You saw at the beginning during that doorbell example how I used Azure Logic Apps to kind of create that process to process the video. But there's actually another way that you can process your functions and orchestrate data. And the other way that I want to spend the rest of the time talking about is a newer piece of Azure Functions, which is, again, very unique to Azure inside of serverless, is called Azure Durable Functions. I have screenshots of durable functions up here on the right, or your left. I'm sorry, on the left. Azure directions are hard. Durable functions, you'll see here, I have one example here in JavaScript and one example here in C#. And what I've actually done here is I'm able to describe orchestrating and calling different functions and activities, but I'm describing that all through code. So to kind of help illustrate why this might be needed, for one, if I'm running in a microservices environment, which serverless is a natural fit in some of these like single function, single piece of functionality type mentality that microservices bring, it's very often that to do something, I'm going to need to call multiple of these things. So durable functions and logic apps are a great way to call multiple. But the other thing to be aware of is for serverless and the serverless plan, a single function can only run for a maximum of 10 minutes, which means if you have a piece of data or some processing that needs to occur that may be running much longer than 10 minutes, that becomes very difficult to manage. And you have to end up splitting up the task. And without something like durable functions or logic apps, you end up having to create queues and do everything yourself. Here with durable functions and with logic apps, you can actually run things that last for a very long time. And we will manage the orchestration and state for you so that these can run indefinitely. So let's talk about Azure Durable Functions. It's an extension that you can pull into your app. There's a bunch of documentation on this. I'd encourage you to look at that documentation as well, because I'm not going to be able to do it justice here in the last 15 minutes. It enables you to run these long-running and stateful serverless orchestrations. You can write these in C# or in JavaScript right now. This slide isn't fully up to date, I guess. JavaScript just got announced last month. This will manage the state, the checkpoints, the queuing, all for you. It's built on top of some open source technology called the Durable Task Framework, which is just an open source framework to enable you to durably execute things. So it's very nice to be able to manage things. So a few patterns that it solves for, just to give you another flavor. It's kind of like function chaining. I have function 1, I want to call function 2, then function 3, function 4. Without durable, I would end up having to do something like this, where I would drop a message into a queue. This one would have to pick it up from a queue, and so forth. That gets really challenging to manage and to monitor and to version. With durable functions, I can just write C# code to say call function 1, then function 2, then function 3. Another popular one, this is one I'm going to show a demo in just a second of, is doing some like distributed fan out, fan in, or map reduce type patterns, where maybe you get a bunch of data and you want to process it across a number of parallel executions. And you can describe this all again in code. Asynchronous responses, where you want to return back a status endpoint and be able to pull until the long-running work is complete. Maybe you have some work that might take 5 minutes to execute, and you don't want to have to keep an HTTP request open for 5 minutes. Durable will provide out-of-the-box patterns for you to say, hey, return back an immediate response, and then do the work in the background and let them check to find out when the work is done. Super, super useful pattern. Monitoring, saying things like, hey, go watch this value for the next hour or the next day and tell me if something changes. Human interaction, one of the cool demos and samples we have with durable functions is doing like a text validation pattern, where you send somebody a code and you wait for them to put that code into like a website or to text that code to a number. It might take them 3 days before they finally read that text message and send back the text. But you could wait that long for that interaction and tie all that together. Obviously, if it's like an authentication thing, you don't want to wait that long, but I'm just saying they can run for a very long time. And again, this is an example. Oh, something dropped. That scared me. This is an example of that first pattern, function chaining. But in C#, I just say, hey, call function 1. Then call function 2, call function 3. I'm even passing in inputs so I can pull data and push data between. And then all of the rest gets managed for me. Let's show an example really quick before I do this piece. I'll do this piece a little bit out of order. So I want to show you this in action. So I have an example very quickly where I have a website. Let me show you the website first. This is a website that's powered by serverless technology. It's beautiful. It was written by one of the Azure cloud advocates. It's a simple store. I could come in here and add some items, go ahead and check out. But the nice thing about this function is that whenever somebody oh, this is an email, not my credit card. whenever anybody comes in here and places an order, let me make sure I put in the right test credit card number. It's actually right here when I push pay. It's calling an Azure function behind the scenes and processing this all serverlessly so that the order process piece doesn't actually take any compute out of my website. Now, this is using Cosmos DB behind the scenes to store all of these orders. And what I want to be able to do is generate a report. So I want to go and say, hey, look at my database and give me the last 7 days of orders. And for each of those orders, there could have been 1,000 orders or 10,000 orders. I want you to go and get the current status of that order. Like, hey, has the payment been processed? Has it been shipped? Has it been delivered? What's the status of that order? And then return to me a report. Now, if I was trying to do this without Durable, this would be really difficult because this middle step here could take a really long time. If I had 1,000 orders that had been placed and I have to do a lookup of a database for each of those 1,000 orders, that could take an hour. I don't know. It depends on how slow my database is. There's no way I could execute that all in a single function. But with durable functions, I'm able to chain this together in code. I'll show you briefly what this looks like and then show you what it looks like. Actually, I'll show you the demo first. Let me open it up right here. And while I wait for this to open, let's go ahead and call that report. So I have here a URL, not this URL. You can see I tested this. I'm going to go ahead and kick off this process to generate a report. So I just put in the URL to that report up here. And what it's immediately returned to me back is some data. It said, hey, I've gone ahead and kicked off this process. This is the URL you can follow to get the status. If you want to add some data, you can post some data here. Or if you want to terminate this, I can terminate here. Let's just go ahead and click the status endpoint. And hopefully I didn't talk too long, and this will still be running. It already completed, so let's do it again. It ran too fast. Let's run another one, and I'm going to click that status endpoint because I want to show you what it does. So you can see right here, it's still running, right? It's still, right now, it's looking at Cosmos. It's spun up a bunch of parallel functions to go look up the status of the database, and it's telling me that it's running right now. And if I go ahead and refresh this, depending on how much data I had, it could have still said running. But in this case, it's completed, and now it's reported data, which said, hey, you have 4 that are preparing for shipment, 1 that's shipped, 4 that are delivered, and 2 that are being processed. So I was able to build this pattern, but have it all running as functions. And the code here, just to give you another sense of what a durable function looks like, this is the orchestration all in C#. So the first thing that I do is I say, hey, go get all of the transactions from Cosmos DB. So that's going to call a function that gets all my transactions from Cosmos. I'm going to do a for each loop to create a bunch of parallel tasks. So for every single transaction I've had, I'm going to go and call the get process function. And here I can just say, wait for all of these to be done. And again, this when all could take an hour. It could take 2 hours. What's really cool here with durable function, and it's hard to wrap your mind around, is that this function isn't actually going to be running the entire time. Whenever there's this await keyword, it's actually going to go to sleep and wait for them to all complete, and that will trigger it to wake up and continue, and then it will return all the details. So a lot of tech here. It's pretty advanced and a little bit complex, but it's worth knowing. And maybe to help visualize it, the last thing I'll show you is how this durable function is running behind the scenes. What's actually happening here? How are we able to run these long-running processes, but still have it be serverless, not having to pay a bunch of money? So here I have a very simple orchestration. This is in C#. All I'm saying is create a new list, call this function called say hello. It says Amsterdam. I should have updated my slides. I'm sorry. I've been doing too much traveling this week. And then add that to a list, okay? But hello, anyone who's watching this stream from Amsterdam once it's published. And that's it. So what actually happens is my orchestration is going to start. It's going to run this first line of code. And so it creates a new list, and it's going to see this await word. And when it sees this await word, there's this thing called the execution history. And the first thing it's going to do is it's going to look at the execution history, and it's going to say, hey, have I already done this action? Have I already had this function have it say hello to Amsterdam? And in this case, I haven't. So it's going to say, nope, you haven't done this before. And the orchestrator's like, OK, cool. I'm going to do this then. So it's going to call that function. It's going to say, hey, function, you have some work to do. That activity functions, and then, it's going to call that function, and then you're going to notice that orchestrator is going to go to sleep. It's going to scale to 0. It's going to disappear. It's done for now. The activity function gets triggered, It's been told it has some work to do. It executes the work, and in this case, the response is hello Amsterdam. Should say hello Norway, I'm sorry. That function's done. That function goes to sleep. And you'll notice all of this has been stored in the execution history. Now, once that activity function is done, it wakes up the orchestrator. So now my orchestrator wakes back up, but here's the part that's important to understand. When that orchestrator wakes back up, it doesn't start from this line right here. It starts from the very beginning again, because there's no way to just like resume a program from the very middle after you've scaled to 0. So the first thing it's going to do is it's going to create a new list. Now it's going to see this await keyword, and it's going to look at the execution history. It's going to say, hey, have we already called Amsterdam or say hello Amsterdam? In this case, it has. Like, it's already done that action. So my history is like, yep, you've already done this thing. My orchestrator says, great, I'm going to move on and do my next step. And then it's going to continue to do its next step and then return back the responses. So every time one of these functions is completed, my orchestration is going to replay. Now, that's extremely important to know because this impacts what your orchestrator can do. It is very important to know that your orchestrator code must be deterministic. You cannot have values in your orchestration that will be different every time it runs. So for example, maybe I have an if condition. I don't want to say if datetime.now equals something, right? Because every time that code gets replayed, the date time is going to be different. Or if I generate a GUID, that GUID is going to be generated different on every single replay, and it can corrupt my state. So never write logic that depends on random numbers, date time, or GUIDs. Okay? Don't do I/O inside of an orchestrator function. Do your I/O inside of your activities. Don't write infinite loops. That's just a good rule in general. I figured we should throw it in every deck. Don't write infinite loops. Make sure that these things terminate. There are patterns, though, for all of these. So if you have something that is running infinitely, there is a safe way to do this in Durable that doesn't result in you having infinite replays. There are ways to do I/O inside of your activities, and there are ways to do, like, get a current date time or generate a GUID or generate a random number. But you need to make sure you're leveraging the built-in pieces of functionality we have in the orchestrator that enable us to do this in a deterministic way, okay? So again, a lot of kind of advanced concepts here with durable functions, but they're extremely powerful for you. The last thing I'll finish with is we've shown 2 ways to orchestrate data now. We've shown just recently durable functions, which lets you do it in code. And at the beginning, we showed you logic apps, which lets you do it in that kind of visual designer that I showed you. So which one should you use? Durable functions is a stateful process orchestrator, not necessarily an integration service. So logic apps has a bunch of out-of-the-box connectors. It has things like Edifact and X12, and the types of things you would expect from a service almost like BizTalk server. Durable is not that rich in those types of features. So if you're looking at something that's doing integration at that level, logic apps may be the better fit. However, there is a lot of healthy overlap between the two. So a lot of it comes down to personal preference. In fact, a lot of times I'll talk with developers and they're like, you know what? I really like how fast I can build things and chain them together and visualize them inside of logic apps. So I'm going to use this declarative workflow. And other people who are like, hey, I'm writing code all day. I think in code. I'd rather be writing this inside of code in kind of an imperative fashion. That's totally cool. That's fine. Like, do whatever one makes you happy, understanding some of the differences in how they execute. For example, logic apps doesn't do that replay between every execution. It will just do action, then action, then action, then action. Durable has that replayability. These two mix and match together very well, and if you're interested, there's even another doc there. But just use whatever makes you happy. That's just a general good rule for all technology. Okay, so that's it for the content I wanted to share with you. Again, thank you so much for coming. I'll hang around here for a few minutes afterwards and answer any questions. If you're interested in learning more or getting started, I'd encourage you to look at our documentation, especially durable functions. There's like 10 pieces of docs and a bunch of samples to get you started if you're interested in trying it out. It's extremely powerful because you can get these long-running processes with the benefits of serverless. We also have a number of quick starts. So if you haven't ever built a function before, we have one where you can do it all within the portal. We have some for Visual Studio. We have some for Visual Studio Code. Whatever editor makes you happy, even some that just use the command line. We've got a bunch of samples, and then some of the advanced patterns I've talked about, like instance management, concurrency control, in-order messaging, error handling. I've written a few of these in my own personal blog if you're interested, which is at medium.com/@JeffHollan. That's also my Twitter handle. I'm more than happy to answer any questions you may have there. So with that, that's it. So thank you all very much for coming. I'll go ahead and answer any questions. There's not a bunch of people in the room, so if you have any questions, go ahead. And then please, just as you leave, you get the little feedback slips. This is my first time coming to NDC. I'm learning exactly how best to do this. They stuck me at the very end of the last day because I was a late entry. But even just those feedback slips will help me know how to improve and hopefully get me invited back as well. So thank you all very much. Any questions? I can answer while we're here. Are we all good? Oh, yes, one right here. Good question. So the question for those who didn't hear is, do the new .NET Core questions get around assembly redirect stuff? So this is a good question. It's a very common one. The challenge that we had with the version 1 of Azure Functions was that for .NET Functions specifically, the desire was to let you have access to very rich data types. In fact, if you look at this example that I had at the beginning, where I was pulling in data from Cosmos DB, I could, as I mentioned, I could say, hey, I want to push a string to Cosmos DB, but I could also say I want to pass in a Cosmos DB document. This is a very rich data type that comes directly from the Cosmos DB SDK. And the way that this is possible is we wanted you to be able to pass rich data types between your function and the host process. And it was a really good idea at the time, and that's how it was built. But the challenge with that is that it means that now your function has some dependencies on the assemblies that the host is using, that host process. So if you want to do something like use a newer version of Cosmos DB than what the host is using, if you try to do that, you're going to get assembly resolution errors when you try to run it, especially when you try to pass data in between, because it's like, hey, this is document version 2, and I use document version 1. So there's a lot of consternation there. So one of the big things we've been doing with version 2 is helping improve that. The short answer is just now, the release that just completed improved a bunch of scenarios. In fact, 95% of the scenarios we're tracking are now much more possible today, but we're not done yet. The next piece we want to do, which should be available in preview by the end of the year, would allow you to run your C# functions completely in a separate process, doing whatever you want on those. It does make it so that things like rich data type transfer would work differently, because we're going to have to serialize and pass the data. But the long story, or I guess the short story is, give it a shot in the v2.1. There's a bunch of things that weren't possible that now we've worked very closely with the .NET Core team to have specific assembly load context for your functions so that you can pull in whatever extensions you want and run them independently. But we're going to continue to work on this through the end of the year so that we never have anybody who has to ask us that. So good question, though. Definitely very high priority. Any other questions? Yep. Yep, good question. So the question was, again, for those who didn't hear, Python support. So we actually have Python running right now in private preview, which is funny to say. And we can give invitations to really anybody who's interested. Just send to me a note on Twitter. So yes, it is coming. It's available right now. We have Python workers. I built a few of these myself. It's not yet in public preview yet. It should be in the coming weeks. But if you're interested in giving it a shot, I'd encourage you to get on board the private preview now, and then keep an eye out in the next few weeks, and hopefully you'll see an announcement where you can use it publicly. And then as the version 2 becomes generally available, it would come available after that as well. Okay, any other ones? Yep, go ahead. Functions with exceptions, you said? What happens to it? Yep. So when your function has an exception, is that like if you threw an exception in here? Oh, a null reference inside. Yeah, so just like any except, like if I wrote code here and I tried to pull in request body and request body was null, what would happen? Yeah, so when exceptions get thrown, your code just finishes and could go away. And that's another really important thing to note is the trigger that you're using. So for an HTTP trigger, for example, if I have an exception that I don't catch and handle in my code, it's very possible that that request just vanished into thin air and I would have lost that data, okay? So one thing is that you can like catch exceptions in your code directly. Some of our triggers, though, do have automatic retries. So if this was coming from a queue instead of a HTTP trigger, if you had something like a null ref exception, we would actually automatically go and retry that a number of times. And if all of them result in exceptions and we retry 5 times, we'll actually go ahead and stick that in a poison queue or a dead letter queue so that you can see, hey, you know, this message had an error and it ended up being a poison queue. So monitoring helps with that. The trigger type is the biggest one on this one, though. If you have data that you want to make sure you don't lose, make sure you use a trigger that can keep some state around like a queue. Does that help? Was that the question? Okay, cool. All right, we'll go with one more. Go ahead. Great question. So I mentioned how these connection strings are environment variables. In the cloud, you would put this type of a connection string in an app setting, which is encrypted, but a lot of people want to keep these in Key Vault. So by the end of this summer, we plan to have a feature where instead of me having to put my connection string directly in an app setting, I would actually be able to do something like Key Vault, something, 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 and have an address to where that secret lives inside of my Azure Key Vault. And we would fetch it out of Key Vault for you using the managed service identity. So it's being worked on right now, targeted to around the end of the summer, where you could reference secrets coming from Key Vault instead of having to put them directly in your environment variables. Okay. All right, I think that's everyone then. Thanks again so much. Enjoy your weekend, 5:20 on the dot. I appreciate you all staying. Honestly, I can't remember the last time I went to the last session of a conference, so I appreciate you all being here. If I had swag, I would give it to you. So thanks again so much.